Okay, what I'd like to do in this video is show you very briefly how you can take the energy stored in bonds and atoms, and there are tables with bond energies. Now these are single bond energies, there are some for double and other sorts of things. But what I can do is I can use these bond energies to predict the enthalpy change for a reaction. What ends up happening, if you think about it with a reaction, is before this chlorine can attach to this iodine, what happens is I need to split these chlorines apart and I need to split these iodines apart. It always takes some energy, so you're always going to put energy into breaking the original bonds. As new bonds are formed, energy tends to be released, and so what happens is if I look at the bond energy, the energy required to break these bonds, and subtract from it the energy that comes out with these bonds, I can predict the delta H for the reaction. So basically what I'm kind of saying then is that the delta H, and let me just kind of put this over on the side here, the delta H for the reaction is going to be equal to the sum of the energy, the bonds broken, so that would be, I don't know how we want to do this, the reactants, minus the sum of the products of the energies of the stuff that comes out of the reaction. My pen is not working very well there. So basically if I take and sum up the energy of all the reactants minus all the products, I can get the energy for the reaction. So what I do is I look in a bond table and I say, well, what is the bond between two chlorines? And if you'll notice two chlorines here, if I join a chlorine to a chlorine, the bond energy would be 242 kilojoules per mole. I would have to put that in to break this. An iodine attached to an iodine has a bond energy of 151. And that's kilojoules per mole. So total, if I'm going to break these guys apart, what's going to happen is I'm going to have to put enough energy in to break all these bonds, and the total requirement there is 393 kilojoules. Sorry, my pen is not working today. So that's the total energy going in. How much energy comes out? Well, a single ICl bond, let's look that one up, iodine and chlorine, is 208. Okay, so I have 208, but I'm going to form two iodine chlorine bonds. So basically I'm going to have to double that. So the total energy that's going to come out of this is going to be end up being 416 kilojoules. So what ends up happening is I'm going to put in 393 kilojoules. 416 kilojoules are going to come out. So again, to figure out the total energy change or delta H for the reaction, I simply take the difference between these two. So I take the total, the sum of the energy of my reactants minus the sum of my products. And in this case, I believe, if I'm doing my math right, that's going to come out to negative 23 kilojoules. So then we would predict this reaction is going to be slightly exothermic. It's not a big deal. I mean, you're not getting tons and tons of energy, because remember, this is kilojoules per mole. All these bond energies are per mole, but you will get approximately 23 kilojoules of energy being released. So this is a very simple way to do this. More complex reactions, I sometimes will actually draw all the molecules out, because one of the trickiest things here is just to make sure you get and count for every bond in the molecule. And as I mentioned also a moment ago, there are tables that have double bonds, triple bonds, and a variety of various presentations and combinations. So very easy thing to do. I recommend you go practice a couple, but not too hard. Good luck.